In this lecture, we're going to talk about radical equations and equations that are quadratic in form. Before we get started, a couple of notes about solving radical equations. Remember, the nth root of a is equal to b means that a is equal to b raised to the nth power, where a and b are both bigger than or equal to 0 if n is even, and a and b are any real number if n is odd. Note that sometimes when we square or cube or raise to the fourth power, etc., both sides of an equation, we get extraneous solutions. So it's very important when we're dealing with radical equations to check our answers. Let's start with an example. The cubed root of 1 minus 2x minus 1 is equal to 0. Now, when solving a radical equation, the strategy is to first isolate the radical, that is, get it by itself. That way you can raise it to whatever power you need to remove it. So to get the radical by itself, we'll add 1 to both sides, giving us the cubed root of 1 minus 2x is equal to 1. Now that we have the cubed root of 1 minus 2x by itself, we can remove the radical by raising both sides to the third power. So 1 minus 2x equals 1 cubed. Next we simplify, giving us 1 minus 2x is equal to 1, and now we can go and solve for x like we normally would. Subtracting 1 from both sides gives us negative 2x equals 0, and then dividing both sides by negative 2 gives us x equals 0. So our potential solution is x equals 0. But remember, with a radical equation we must check our answer. So we can plug 0 in for x for our original problem, giving us the cubed root of 1 minus 2 times 0 minus 1 equals 0, and we want to verify that this is true. Now 2 times 0 is 0, so underneath the radical we'll wind up with the cubed root of 1 minus 1 is 0. The cubed root of 1 is 1, so we have 1 minus 1 equals 0. And 1 minus 1 does equal 0, so this checks out. This means that x equals 0 is a solution. Here's another example. The square root of 12 minus x equals x. The radical is already by itself, so we don't have to worry about isolating it first. So we can continue by removing the radical. If we square both sides of the equation, the radical will go away, leaving us with 12 minus x equals x squared. Since there's a squared term here, this will be a quadratic equation, so we want to get all terms on the same side of the equation. If we add x and subtract 12 from both sides, we'll get 0 equals x squared plus x minus 12. We can factor the quadratic out, giving us x plus 4 times x minus 3. Then we use the zero product property, so 0 equals x plus 4, or 0 equals x minus 3, and we can solve for both of these equations, giving us x equals negative 4, or x equals 3. Now we need to check and see whether these answers are true. We'll start by plugging negative 4 into our original problem. So the square root of 12 minus a negative 4 equals negative 4. Simplifying, 12 minus negative 4 is 16, so the square root of 16 equals negative 4. But by definition, the square root of 16 is positive 4. So we have positive 4 equals negative 4, and this is not true. Positive 4 does not equal negative 4, so negative 4 is not a true solution. It is an extraneous solution. We can plug in 3 to check if it is a true solution, so the square root of 12 minus 3 equals 3. Simplifying under the radical, 12 minus 3 is 9, so the square root of 9 equals 3. And the square root of 9 does equal 3, so this verifies that x equals 3 is a solution. Here's an example that's a little bit more challenging. The square root of 3x plus 7 plus the square root of x plus 2 equals 1. Remember, the strategy for solving a radical equation is to isolate the radical. So we want to get one of these radicals by themselves. To do that, we can subtract the square root of x plus 2 from both sides of the equation. So the square root of 3x plus 7 equals 1 minus the square root of x plus 2. To remove the radical on the left-hand side, we can square both sides of the equation, and that'll give us 3x plus 7 equals 1 minus 2 times the square root of x plus 2 plus x plus 2. As a reminder, the right-hand side, we had 1 minus the square root of x plus 2 quantity squared, Remember, you can write that as 1 minus the square root of x plus 2 times 1 minus the square root of x plus 2 and FOIL it out to get the right-hand side that we have here. Next, we're going to combine like terms on the right-hand side. So we'll have 3x plus 7 equals x plus 3 minus 2 times the square root of x plus 2. Now we want to isolate the other radical. We want to get the square root of x plus 2 by itself. So we will subtract x from both sides of the equation, and we'll subtract 3 from both sides of the equation. This gives us 2x plus 4 equals negative 2 times the square root of x plus 2. To get the radical by itself, we'll divide by negative 2, and that gives us negative x minus 2 equals the square root of x plus 2. To remove the square root sign, we can square both sides of the equation, and that'll give us x squared plus 4x plus 4 equals x plus 2. Now this will be a quadratic equation again, so we want to get all terms on the same side of the equation. We can start by subtracting x from both sides of the equation, and then we'll also subtract 2 from both sides of the equation, which gives us x squared plus 3x plus 2 equals 0. Now to solve this, we can use the quadratic formula or factoring, whichever you're more comfortable with. I'm going to solve this by factoring. So we can factor the left-hand side to become x plus 1 times x plus 2 equals 0. We use the zero product property, so x plus 1 equals 0 or x plus 2 equals 0. And if we solve both of these equations, we'll get x equals negative 1 or x equals negative 2. But remember, since we had square roots, since this was a radical equation, we need to check both of our answers. So I'll leave that as an exercise for you. Check and see which of these answers are true. And you should have found that x equals negative 2 is the only true solution. Next, we want to talk about solving equations that are quadratic in form. For example, consider the equation x to the fourth minus 10x squared plus 25 equals 0. Now this isn't actually a quadratic equation, but we can rewrite it so that it is what is called quadratic in form. That's where we'll have the term squared in the first term, the same term in the second term, and the constant in the third. So we can rewrite our equation in terms of x squared. X to the fourth is x squared squared minus 10x squared plus 25. So this is quadratic in form. And the easiest way to solve a problem that is quadratic in form is to use a substitution factor to rewrite it. So let's let u equal x squared. We can rewrite our problem. Rewriting our x squareds with u's will give us u squared minus 10u plus 25 equals 0. And we can solve this quadratic equation using factoring or the quadratic formula. We'll factor here. This factors out to be u minus 5 times u minus 5 equals 0. And so we can find out that u has to equal 5. But remember, our problem wasn't in terms of u, it was in terms of x. So we need to go back and find out what x would be if u is equal to 5. So let's reuse our substitution from before. If u equals 5, then that means that x squared will have to equal 5. So x squared equals 5. We can now solve this using the square root method. We take the square root of both sides of the equation, and we see that x equals plus or minus the square root of 5. Let's look at another example. This time we have 2x plus 5 quantity squared minus 2x plus 5 minus 6 equals 0. Now there are two ways that we can solve this. The first way would be to go ahead and FOIL out the 2x plus 5 squared and then combine all of our like terms and solve the resulting equation. The other way would be to use the fact that this is quadratic in form and use a substitution factor. So let's assume that u equals 2x plus 5. This means we can rewrite our problem as u squared minus u minus 6 equals 0. Now we can solve this quadratic equation by factoring. It factors out to be u minus 3 times u plus 2 equals 0. If we use the zero product property and solve, we'll get that u equals 3 or u equals negative 2. But again, remember, our problem isn't in terms of u, it's in terms of x. So we need to take one final step. We'll we'll redo the substitution and then solve for x. So if u equals 3 or u equals negative 2, that means 2x plus 5 equals 3 or 2x plus 5 equals negative 2, and we can solve both of these equations for x. Starting with 2x plus 5 equals 3, we subtract 5 from both sides to get 2x equals negative 2, then divide by 2 to get x equals negative 1. And for 2x plus 5 equals negative 2, we could subtract 5 from both sides to get 2x equals negative 7, and then divide by 2 to get x equals negative 7 halves. And the last topic that we'll talk about in this lecture is solving equations by factoring. So to solve an equation by factoring, we're going to collect all terms on one side of the equation, then we'll factor out that expression, and then we'll set each factor equal to 0 and solve. So for example, if we want to solve x to the fourth minus x squared equals 0, we can start by factoring out a common term. We can factor out x squared, making this x squared times x squared minus 1 equals 0. And we can further factor out the x squared minus 1 since it's the difference of two squares. We can rewrite this as x squared times x minus 1 times x plus 1 equals 0. Now using the zero product property, we can set each factor equal to 0, so x squared equals 0, x minus 1 equals 0, or x plus 1 equals 0, and then solve for each of these. For x squared equals 0, we can take the square root of both sides of the equation, and we get x equals 0. For x minus 1 equals 0, we can add 1 to both sides of the equation, and get x equals 1. For x plus 1 equals 0, we can subtract 1 from both sides of the equation and get x equals minus 1. Here's another example. X to the fifth equals 4x cubed. In order to solve this, we first need to get all of the terms on the same side of the equation. So if we subtract 4x cubed from both sides, that will give us x to the fifth minus 4x cubed equals 0. Now we want to factor out common terms. We can factor out an x cubed, giving us x cubed times x squared minus 4 equals 0. And we can factor x squared minus 4 further, giving us x cubed times x minus 2 times x plus 2 equals 0. We use the zero product property to split this up, so x cubed equals 0, or x minus 2 equals 0, or x plus 2 equals 0. And we can solve each of these equations to get our solutions. If x cubed equals 0, we would take the cubed root of both sides and get x equals 0. If x minus 2 equals 0, we would add 2 to both sides to get x equals 2. And if x plus 2 equals 0, we would subtract 2 from both sides to get x equals minus 2. Let's do one final example. We want to factor and solve x cubed minus 3x squared minus x plus 3. There are no common terms to factor out here, so let's try to factor by grouping. We group the first two terms together, and we group the second two terms together, keeping in mind that the negative with the x has to stay inside the parentheses. And we factor a common term from each group. From the first group, we could factor out x squared, giving us x squared times x minus 3. And from the second group, we could factor out a negative 1, giving us minus 1 times x minus 3. We have a common term between both groups, which now can be factored out, leading us to x squared minus 1 times x minus 3 equals 0. Now we can go ahead and use the zero product property here. X squared minus 1 equals 0, or x minus 3 equals 0, and we can solve for each equation. If x squared minus 1 equals 0, we can add 1 to both sides, giving us x squared equals 1, and then take the square root of both sides, giving us x equals plus or minus 1. And if x minus 3 equals 0, we can add 3 to both sides, giving us x equals 3.